Dun, 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 dun. Ladies and gentlemen, the Projectile Motion Lab. In this lab that you are going to begin on Tuesday, you are going to need to find, for a given initial velocity, initial angle, and initial position, the maximum height, the position of the maximum height, the horizontal position of impact, and the velocity of impact. I know what you're thinking. This is the most exciting thing you've ever seen. It's the moment you've been waiting for. I know. You're welcome. So let's get after it. Let's take a look at the situation that you're going to have. Imagine, if you will, that this is Miss B's AP Physics classroom. On her counter, she is going to set up the projectile motion gun, the Benny gun, and she's going to ask you to find, as the end goal of this entire lab, the maximum position in the y direction of your projectile. So you're going to need to find the maximum position of your projectile. And not only are you going to need to find that position, you're going to need to find how far away from its initial position in the horizontal that you have it. And the way that I'm going to know, in addition to looking at your calculations, that it was done is you're going to, on the day of your launch, you're going to set up a goalpost so that if your calculation is wrong, the projectile will not make it over the goalpost, or will be far too far over the goalpost, and you will not be able to complete this lab. Additionally, you're going to need to find the horizontal position of impact and the velocity of impact at the horizontal position. That is how far away in the horizontal direction you are from its launch point, and you're going to need to do that to an accuracy so that if I put a bullseye with carbon paper underneath it on the ground there, when you do your launch and your projectile makes impact, it will impact on the bullseye. If it does not make an impact and does not make a carbon negative mark, you will not have completed the lab. Then from the values collected within the lab, you are going to need to determine what the velocity of impact was. Not the x component, not the y component, but the actual velocity vector. Good news is you have several knowns for this lab. You're going to know your initial velocity. You're going to know your initial angle of launch, and you're going to know your initial position in the vertical direction. But in order, and it's okay if you set your initial position in the horizontal direction to x. Yeah, you're welcome. You can do that. But before you can do that, you're going to need to figure out what your initial velocity is for your launch. And you might say to me, Miss B, that's no fair. That sucks because I don't know what the velocity of the Benny gun is. Well, that's what you're going to be figuring out on Tuesday. And I'll tell you what. I'm going to give you your initial angle that you'll be launching at. So please make sure to check the assignment and check the spreadsheet so that you know what your initial angle is going to be. And then you're going to have three options. There's three different velocities that the Benny gun can have. There's the long range velocity, which is the V0 initial L. There's the medium range velocity, which is the V0 initial medium. And there's the short range velocity, the V0 short. I'm going to assign one of these to you, and your goal on Tuesday is going to be to figure out what those velocities are, because if you don't know those velocities, you will not be able to complete the other part of the lab. In class on Tuesday, I'm going to shoot once of each long, medium, and short range at 45 degrees. So you're going to know the angle 45 degrees. You're also going to be able to collect and use the x and y components to find the initial velocity of your range, which doesn't sound too bad because you know the x and y pilot equations. But there is one caveat, and that caveat is that time is not reliable. And since time is not reliable, we've talked a lot before about how reaction time is significant. So for a very short period measurement, that time is not going to be very accurate, and that's going to ruin your X and Y measurements, and it's going to cause you to fail the lab. It means that your time is going to be an unknown, and you're going to have to be able to calculate for the initial velocity without using a time value. And if you've been paying attention to the lectures that we've done up to this point in time, then perhaps you've noticed, if you've watched the range lecture, if you watched the 3/7 projectile parabola lecture, that there's maybe going to be a system for you to use to solve for the velocity without using the time value. And that system is got to be a system that relates the X values and the Y values in some way. There is a link between these two completely separate types of motions that you can analyze to solve for your unknown initial velocity for your given range. So let's go ahead and let's go back to Miss B's classroom. All right, Miss B's classroom. There's a few things that you're going to need to do. Notice that the setup is the same, but on Tuesday I'm going to shoot once at short range, once at medium range, and once at long range. You're going to need to set your axis. My recommendation is that the y-axis is in the positive direction and that the x-axis is positive, so that when your displacement in the x direction is complete, you have a positive value. So that means that you're going to need to set your origin. You're going to have an unknown V0. Your initial angle is going to be 45 degrees, and you're going to have to collect the initial position, the final position, the initial position in the x direction, the final position in the x direction. And these values, and only these values, in the kinematic equations for the X and the Y pilot, are going to allow you to accomplish your ultimate Tuesday goal, which is to solve for your initial velocity for either short, medium, or long range from the Binny gun. You are going to need to calculate it using these values, because once you have that calculated, you're going to need to spend the rest of your time on Tuesday calculating your end goal pieces. The y max, the x at y max, the x of impact, and the velocity of impact. Because on Thursday, when I do the launch for you, you're going to need to have your goalpost set up so that it passes over the goalpost and lands on the target. If it does not, you do not complete this lab. That means that in order for this to be done successfully, you're going to need to come into class on Tuesday with the following things done. Number 1, the background.
Hey Hawks, sorry for the interruption. Today at lunch, an error on the royalty ballot was found. Two of the candidates' names were missing from the ballot. To correct this error and to ensure fairness for all candidates, we will be deleting all votes from today and allowing all students to revote tomorrow or Monday at lunch. So remember, if you voted today, please come back to vote, and if you missed your chance to vote today, you still have 2 more chances. Homecoming royalty is decided by the entire student body, so make sure to go check out the royalty board in the cafeteria before voting tomorrow or Monday. Thanks, Hawks, and have a great day.
You need to be ready on Tuesday immediately to collect data and calculate. That means your background needs to be done, your purpose needs to be done, and your setups need to be done. This lab and your notebook are both getting collected on October 7th to go into your quarter grades. So that means that everything in your notebook up to this point in time, including this lab, are going to need to be done and written up by then. All right, that's it. Good luck. Have fun doing calculating, and I will see you at the launch.